Good day, seniors. This video lesson will be studying about the Vieta's theorem or the Vieta's formulas. This is really simply about the relationship between the roots of a polynomial and its zeros. So in this case, if the zeros of a polynomial, in this case we'll be focusing on a third degree polynomial or a cubic polynomial. The roots are R, S, and D. The coefficients you know are A, B, C, and D. So it simply is this R plus S plus T, the sum of the roots will be given by negative D over A. The product of the roots taken 2 at a time, RS plus RT plus ST, simply C over A. And the product of the 3 roots, RST, is negative D over A. Now let's have some problems to answer. If P, Q, and R are the roots of x cubed plus x squared plus x minus 8 equals 0, what is the value of this expression? It's a very long expression. P cubed plus 2p squared plus p plus q cubed plus 2q squared plus q plus r cubed plus 2r squared plus r. But before we go into that, you set up your Vietas first. You set up the sum of the roots, p plus q plus r. And you know it's equal to negative b over a. I'm talking about the coefficients here. So you have negative 1 over 1. It's negative 1. The product of the sum of the product of the roots taken 2 at a time, pq plus pr plus qr, is of course c coefficient over a. So that's 1 over 1 or 1. And then finally, the product of those 3 roots pqr, so p times q times r, is negative d over a. So the negative of negative 8 over 1. So that will give you positive 8. So these 3, we will be using these 3 values to evaluate the exact value of this expression. Now, noticing that the expression can be grouped into its degrees. Let's say we group all the terms with the power 3, p cubed. So this will be p cubed plus q cubed plus r cubed. So that's our first group. Let's cross mark this out. Then grouping all the terms with the second power. So we have 2p squared, 2q squared, and 2r squared. And factoring out 2 to get here p squared plus q squared plus r squared. So we've used this 2, this 3. Then what's left is p plus q plus r, which is one of the 3 that we set up earlier. So this is actually negative 1. So we have the value of this. So what we should do now next is to get the value of p cubed plus q cubed plus r cubed, and then p squared q squared plus r squared. This. Now, this is simple to derive, but let's have the formula to use right away. This is for the cube, r cubed plus s cubed plus t cubed is this. Notice that the sum of the cubes is represented using the Vieta's coefficients. So PQR, PQ plus PR, QR, and then PQR. In this case, we're having RST here. And then this is for the sum of the squares. So we will be using this to evaluate exact value of this group and this group. Okay, so let's use the space here. So let's start with the sum of the squares. So p squared plus q squared plus r squared is equal to, so just replace all the letters with pqr respectively, pqr and then pq, pr and then qr. So this was simply p plus q plus r and then squared minus 2 times pq plus pr plus qr. And notice again that these are the values that we have set up earlier. P plus q plus r is negative 1, so this is simply negative 1 squared minus 2 times pq plus pr plus qr, that's 1. So this is simply negative 1 minus 2 or negative 1. So p plus q squared plus r squared is negative 1. So we can now replace all, though we know, say p plus q plus r, yes, we know that this is simply negative 1. And then here, that's 2 times p squared plus q squared plus r squared, which we got negative 1. So what we're left with is to find the value of the sum of the cubes. So let's do that. So let's erase part of our formula first. This time we'll be using this relationship. So this time the derivation for this is simply the same expansion and some factoring. So here we have p cubed plus q cubed plus r cubed. That is simply p plus q plus r. Again, the letters are p, q, and r for those three. P, q plus r, and then cube, minus 3 times the sum of the product of the terms taken two at a time, pq plus qr plus pr, times the sum of the terms p plus q plus r, and then added to 3 times, this is the incomplete, that should be 3rst, so there's still an s there. So anyway, so this should be 3pqr. So the point is, we know all these values because these are the values that we got from the Vieta's theorem earlier. P plus q plus r is negative 1, so this is simply negative 1 cubed. So negative 1 cubed minus 3 times this pq plus qr plus pr is this here 1, and then p plus q plus r is negative 1 plus 3 times the product pqr, which is positive 8. So we can get the exact value of the right side, which is negative 1 plus 3, that's 2, plus 24, so we get here 26. So meaning p cube plus r cube plus q cube is equal to 26. So this is simply 26. So now we know all the values that we need. The exact value of the expression is simply 26 plus negative 2 plus negative 1, or 23. Right. Let's have the next problem. Suppose r, s, and t are the roots of polynomial f of x equals x cubed plus 20x squared plus 13x plus 42. And so before we go into the second condition, knowing that r, s, t are the roots of f of x, we can get these relationships from your Vieta's theorem. Rs plus t is simply negative b over a, that's negative 20. The sum of the product of the roots taken two at a time, rs plus rt plus st, is simply c over a, that's 13 over 1, that's 13. And finally, the product of the roots rst is c of negative d over a, or negative 40. Now, let's read the next condition. It said that 1 over r, 1 over s, and 1 over t are the roots of another polynomial g of x equals x cubed plus ax squared plus bx plus c, and it's equal. And the question here is, what is a plus b plus c? Of course, we need to find a, we need to find b, we need to find c, so we can add and get the final answer. Of course, if 1 over r and 1 over s and 1 over t are the roots of g of x, so using those three for Vieta, so you have 1 over r plus 1 over s plus 1 over t. This is actually negative of the coefficient of x squared over coefficient of x cubed, so that's negative a, right? So then 1 over r, the product of those, of the sum of the product of these three roots taken two at a time, so 1 over r times 1 over s, so you have here, and then the product 1 over r times 1 over t plus 1 over r and 1 over s times 1 over t. So again, the product of this sum of the products of these three roots taken two at a time is simply the coefficient of x over the coefficient of x cubed, which is b. And then finally, the product of these three roots is simply 1 over r times 1 over s times 1 over t, or 1 over r st. When we multiply, that is equal to simply negative c over a. So to get negative c over the coefficient of x cubed 1, which is simply negative c. So now we have the a, b, and c in terms of r, s, t. All we need to do is to evaluate each one. So let's start with this. So you have 1 over r plus 1 over s plus 1 over t. So simplifying, knowing this is equal to negative a later. So this is simply combining the fraction rst divided by r, give you st. Rst divided by s, that will give you rt. And then rst divided by t, that's rs. So notice that the numerator is simply this, 13, right? The denominator rst is the product, negative 42. So this is simply negative 1 4 times 3, 12. No, it's not. It's negative 13 over 42. So it cannot be simplified anymore. So if negative a is equal to negative 13 over 42, then that means a, so put it here, a is equal to 13 over 42. So now we know a. Let's go to solving the value of b. This time we're dealing with that. So I'm erasing part of my solution. Now 1 over r times 1 over s, that is of course 1 over rs. 1 over r plus 1 over t, that's of course 1 over rt. And then 1 over st. Combining this, of course, the LCD again is rst. Divided by each denominator, you will get here t in order, t plus s plus r, which I hope you can notice right away that the numerator is again negative 20, the sum of the roots. The denominator is negative 42. So negative 42. So we have here 20 over 42, which of course we can still simplify, but since we're adding a plus b and c later, I'll just leave it as is, 20 over 42. So if the whole thing is 20 over 42, then so is b, 20 over 42. So let's write here b equals 20 over 42. Now to get the value of the last one, which is the easiest, so 1 over rst is simply negative c, and we know that rst is negative 42. It's 1 over negative 42, which is equal to negative c. So therefore c equals 1 over 42. Simple as that. So let's write it there, and then so now we have c equals 1 over 42. So the value of a plus b plus c, which the question in the first place is simply 13 over 42 plus 20 over 42 plus 1 over 42, or 34 over 42. And you simplify your final answer, divide by 2, that's 17 over 21. That's the ABC, sum of ABC. Now, of course, need to practice to understand Vieta's theorem more. There are many problems in the handout. Let's handout 1.11. So there are problems that we haven't answered that yet. You make use of them for practice. So the best way to learn, do it yourself. Today, seniors, peace out.